What is electromagnetic induction? Electromagnetic induction is a process in which we generate electricity in a conductor using a magnetic field, or in other words, we induce it. This phenomenon was first explained by Joseph Henry, who stated that whenever charges move from one point to another point within a conductor, a magnetic field is produced around them. Consequently, it follows that if a changing magnetic field passes through a conductor, it should cause the charges inside to move from one point to another point. In other words, just as an electric current produces a magnetic field, a changing magnetic field should also produce electricity. Essentially, for electromagnetic induction to occur, there must be a change in the magnetic flux through the conductor. If the magnetic flux remains constant or does not change, then electromagnetic induction is unable to take place. For electromagnetic induction, we need one of the four methods. The first method is the relative motion between the source of the magnetic field and the conductor of a coil. When there is a relative motion between the conductor and the magnetic field, the magnetic flux through the conductor changes, induce an EMF within a conductor. The second method is by changing the current within a coil. When the current in a coil changes, the magnetic field around it also changes, which induce an EMF within a coil. The third method involves rotating of a coil within a magnetic field. As the coil rotates, the magnetic flux through it changes, leading to an induced EMF. The fourth and the last method is by changing the current in a nearby coil. In this case, we have two coils, a primary coil and a secondary coil. When the current in the primary coil changes, the magnetic field around it also changes, and this varying magnetic field induces an